All right, the difference quotient. This is one of my favorite topics in this course. Ooh, how am I doing on time? I may have to go in just a second. Oh, I've got time. So the difference quotient, what this is, it's for finding the slope between points on a curve. In algebra class, every algebra class, there's this focus on linear equations, finding the slope of linear equations, graphing linear equations, etc. In that case, it's relatively easy. If I have a linear equation like y equals mx plus b, my slope is just a number. Remember, looking at a graph, your slope says that if you take any 2 points in your graph and you take the rise, which is the distance you go up between these points, and then the run, which is the distance you're going over, if you take that rise and you divide it by the run, you've got your slope. And that's just going to be a nice constant. It's going to be a fraction of some type or a whole number, but it's something that's not going to change. So, this first case, finding the difference quotient for the following function, 3x minus 1. Since the difference quotient is just the slope, the difference quotient in this case is 3. Now, we're going to work this out using our definition of difference quotient in just a minute. Sorry, I got distracted here. In just a minute, we're going to find the difference quotient using our formula. But just to keep this consistent with what we've already learned, I want to talk about this as just being your slope. Now let's look at, before we get too far, I want to look at where this comes from. So I really want to emphasize this idea that we're just looking at a slope. So the idea here is if I take an x and a y value, if I take an x-axis and a y-axis, and I'm going to choose 2 points. Let's say I have some wacky curve go through here. And I'm going to choose 2 random points on our curve. I'll choose this point and this point. With those points, I can find the x value. I'll call this first one just x. And then what is my y value? Well, for a point, for an x value of x, I would just be plugging in x to my function. So I've got an ordered pair here, x and f of x. Okay, I'll just write it down here, x and f. So I've got an ordered pair, an x and a y. Over here, what I'm going to do is I'm going to go a little distance along the axis here. I'm going to go a distance of h, just an arbitrary distance. We like to talk about arbitrary distances. Really starting with calculus. So if I've gone, I'm looking at my x-axis, I've gone to this point x, and I've gone a little bit further, I've gone an additional h. What is my new x value? Well, I can write it as x plus h. So that makes sense. I had gone x, I went an additional h, so I've gone x plus h altogether. So just like before, since I've got an x value, I could find the y value associated with that. It's just f of what? What was my x value? My x value was x plus h. So now I've got a second ordered pair. My x value this time was x plus h. My y value was f of x plus h. Now I want to look at my slope formula. Slope was y2 minus y1 over x2 minus x1. In our case, our y2, let's call it our y2 right here. So that was f of x plus h. My first y value will be up here, y1. That was just f of x. So I'm going to subtract f of x. And then I want to divide by x2 minus x1. So this is my x2, x plus h. And then x1 was just x. So subtract x. This can simplify a little bit. We can't simplify the numerators here. But the denominator, we've got an x and a minus x, which we can cancel out. And that leaves us with f of x plus h minus f of x over h. And that is our difference quotient. That's where it comes from. Now we can talk about why this is such a useful thing. What we've done here is we found the slope between these 2 points. If I were to draw a line right here, I found the slope of that line. Since h was an arbitrary distance, what you do in differential calculus, which is Cal 1, or if you're taking business calculus or calculus for the engineering sciences or calculus for natural sciences or biological sciences, any of our calculuses we offer, you'll cover this. So, since h was arbitrary, what you do in calculus is then you take the limit of this thing. We say the limit as h gets smaller, or the limit as h goes to 0. So the idea is, as h is shrinking, so our distance here is shrinking. We're slowly getting closer and closer together. We make our points closer and closer. When we say the limit, we want to know what happens to our slope. You know, what will happen to our slope. And that's not something we do in algebra. That's what you'll do in calculus. There are tricks to it. A lot of cases it's really easy to do. But we won't be worrying about that. But I just want to give you a preview. So what happens as h gets smaller and smaller? So like if I cut h in half, now we'd be looking at this for a second point. And we've got if we were to calculate our slope there, we would get a little steeper. If I cut h in half again, I would have the slope of a new line, which is, again, even steeper. And you can keep doing this until the points are right next to each other. And in that case, we have our final slope. We call it the slope of the tangent line. Slope of tangent line. Also known as the derivative. And that's what that's what calculus, or at least differential calculus, is all about. You can always think of this in terms of the slope of a tangent line. So going back up to our first function, f of x, we want to use our formula f of x plus h minus f of x over h. We want to use that formula to prove that our difference quotient here is just equal to our slope. So what I'm going to do is I'm going to start off by finding f of x plus h, and we've looked at this now. We know how to evaluate a function at some crazy thing, some crazy expression. So what do? I just need to plug all this mess in for our x. I always like to write this as 3 times blank minus 1. So I've replaced my original x with just a blank spot, and I'm being asked to plug in x plus h, so I'll go ahead and plug in x plus h. To simplify this, there isn't a lot to do. I just want to distribute my 3 to get 3x plus 3h. I've got my minus 1. And I've got this done. I've found f of x plus h. So in my formula, I need to plug in this f of x plus h, which we just found. I need to plug in my original function, which they gave us. And I'm going to plug in this h, which is just a new variable. There's nothing down there other than this h. So I want to take my function here, my f of x plus h, and then I'm going to subtract my original function from it. So I'll write that out as a second step over here. So step 1 was finding this f of x plus h. Step 2, I'm going to go ahead and calculate f of x plus h minus f of x. So f of x plus h was right here. 3x plus 3h minus 1. And now I'm subtracting my original function. I'm going to subtract 3x minus 1. In order to do that subtraction, I distribute my minus sign. So minus 3x plus 1. And I should have a lot of terms that cancel here. 3x minus 3x will cancel. They're not always going to cancel. For a linear equation, they should. Minus 1 and plus 1 will cancel, and so I'm left with 3h. So I found f of x plus h. I've now calculated this difference. My last step is to divide it by h. So that's step 3. I'm going to divide by h. And when I do that, so I've got 3h, I'm dividing it by h. What happens? The h cancels. I'm left with 3. And that is my final answer here. My difference quotient was 3, which I told you to begin with. This is going to become much more complicated, or not more complicated, there's just more steps involved when we have to square x squared. Okay. So I'll do this. Step 1, evaluate our function of x plus h. So it's going to be blank squared minus 3, right? Because I replaced my x with a blank. And now I'm plugging in x plus h. So in order to square that, I'm going to take it and multiply it by itself. And subtract 3. In order to calculate this, I'm just going to FOIL. And I get x squared plus xh. I don't know why I wrote that twice. Plus xh plus hx plus h squared minus 3. Now notice our middle terms, xh and hx. The order of that does not matter. We could write them as both hx. We could write them as both xh. The important thing is, since we have 2 of them, we can combine them as just 2xh. And carry down our other terms. Carry down x squared. Carry down the h squared, carry down the 3. So that is our step 1. We've calculated our function. Step 2 is going to be subtract our original function. So I'm going to take all this taking my formula I just found, I'm subtracting the original function. So I'm subtracting x squared minus 3. Once again, you've got to be real careful with your minus sign. Make sure you distribute that. So that gives you a minus x squared plus 3. And carry down our other terms. If we've done this correctly, we should have something that cancels. And it looks like we've got an x squared and a minus x squared that'll cancel. We've got a negative 3 and a positive 3 that'll cancel. So I don't have a whole lot. I've just got these terms, 2xh plus h squared. So for step 3, I'm going to take my 2xh plus h squared, and I'm going to divide it by h. So when we're dividing, as long as both our terms in the numerator have this h in it, which they do, as long as they both have an h, I can cancel an h out of each of them. So out of the first term, I cancel an h. Out of the second one, to cancel an h, I'm just going to cross out that exponent. So instead of 2 h's, now I've got just the h. And of course, I have to cancel the h in the denominator. What am I left with? I'm left with 2x. 2x plus h. So for a linear equation, difference quotient is just the slope. For a more complicated function, like a quadratic, you're going to get a more complicated difference quotient. But there it is. There it is. There's your introduction to calculus for the day.